Hello friends, welcome to my class of physics. Now today I am going to discuss the wave theory of light, which is basically the foundation of interference phenomena. Now what is interference? Interference of light is the modification of intensity due to superposition of two or more waves of lights. Now to understand this we need to know how a wave propagates and how we can write a wave equation. Now let's take one example to understand this. So if we throw a stone in a pond, what happens? Where we throw the stone, from there waves is generated. We have seen that. So we have seen that water level goes up, and in some region water level goes down. Right. So here this xy basically represents the level of the medium when it is not disturbed, and at A and B point the medium basically goes up from xy level, and these are called the crests, and at C and D point the medium level goes down from xy, so these are called the troughs. Okay, now here in the figure you can see we have drawn some arc of circles, right? So some are solid, some are dotted. So in the crest points you can see we have drawn some solid arcs. So what is that? So if you see the nature of the wave in the pond, so all the points all the points goes up in a particular distance from the source. So basically what I want to mean, that if we consider a radius from that center where you are throwing your stone, now if we draw a circle, at all the points on the circle basically are in the same phase, means all the particles, water particles, vibrate in the same way. So if the waves are going up, means all the particles are going up. If the waves are going down, that means all the particles are going down. So for a particular distance, if we consider all the water particles are vibrating in the same way, either in upward direction or in the downward direction. So if we connect all the particles, we will get a circle, and this portion here you can see it is an arc of that circle, a small portion of that circle. So for crest regions where all the particles are going up, we are representing in the solid lines, and the trough region where all the particles are going down, if we connect all the points, the locus of the points, it represents this dotted line in the trough region. Now the distance between these two consecutive crest and troughs are basically called the wavelength, that we represent as lambda, and the distance of crest or trough from xy level is actually representing the amplitude, which we are denoting as a here. Okay, now as you have seen, when a wave propagates through the medium, the displacement of the molecules of the medium will be perpendicular to the direction of the propagation. So that's why this is the transverse nature of the wave. So light is a transverse wave. Now when a transverse wave propagates, molecules or particles of the medium execute simple harmonic motion about their equilibrium position, that is the xy level we have seen. Now the state of vibration of vibrating particles is called the phase of the wave. Now all the particles on the crests are vibrating in the upward direction, and all the particles on the troughs are vibrating in the downward direction. So that's actually seen in the figure. You can see on the crest all the particles are vibrating in the upward direction, and the trough all the particles are vibrating in the downward direction. So if we connect the locus of all the points in crest and trough, we basically get some circles. So these circles are nothing but the wave front here. Okay, so that we will discuss in the next lecture in detail. Now let's see how we can write the wave equation. The equation of motion of particle which is executing simple harmonic motion, that we can write as y equal to a sine omega t. Okay, now omega is nothing but 2 pi by t, so that's why it is written a sine 2 pi by capital T then small t. Now at a distance x from the first particle, another particle also executes simple harmonic motion, so there will be a phase difference between them. So the phase difference between those two particles, if we write phi, that is basically 2 pi by lambda into x. So equation of motion of the second particle, we can write y equal to a sine omega t plus phi. So that is that extra phase that second particle have with respect to the first particle. So generally the wave equation we can write y equal to a sine or cos omega t plus phi. Okay, thank you.